So now we're going to do the calculations for ideal gas law. So ideal gas law is going to be PIV. P B equals nRT. Your P is going to be pressure. Pressure times volume equals N, which is mole, and then R, which is your gas constant, which is going to be, which is gas constant, which is either going to be I just lost it, here or here, depending on what your units are. So for the most part, it's 0.0821 LATM per mole K times temperature. So a few things that you need to do, right? So one is make sure your temperature is in Kelvin. Okay, because we can't have negative volume, pressure, or moles, so your temperature needs to be in Kelvin, right? And here comes our rhyme, right? If you see degrees C, add 273, right? We learned that a while ago. If you see degrees C, add 273. And the other thing is, right, you need to do grams to mole conversions. Okay. So the way that you identify this instead of combined gas law is that there's going to be one of each. If it talks about mass and mole, it's probably going to be ideal gas law, all that. And the reason that it sets up this way is because if you think about it, number of particles and pressure is directly proportional. So as you add in particles, the more pressure that you get, because the more the particles run into each other. And as you increase temperature, the more the particles collide, so the more pressure builds up. So because N and T are directly proportional to P and V, we can just bring it to the other side. Okay, so let's go through some sample problems. Okay, you don't have these problems. This is from an old sheet. I just want to show you how to do it. Okay, if I have 2.4 moles of gas held at the temperature of 97.0 degrees Celsius in a container with a volume of 45 liters, what is the pressure in kPa? Okay, so there are multiple ways to do this, and let me think about how I want to do this. Okay, so in this situation, let's just do this. N is equal to 2.4 moles. Temperature is in degrees C. Uh-oh. So what do I have to do? Add 273. So 3 plus 7 is 10. Now add 1. So it should be 370. Pretty confident on that. 370 K. My volume is going to be 45 liters. And and I know my R, and I am calculating for P in kPa. Okay, so I can do this in a few ways. If I'm sticking with the 0.0821 LATM, I have to convert at the end. But we also gave you the gas constant if we're doing it in kPa as well. Okay? So look at your blue sheet or whatever colored sheet that you have. Let's see what Pre-AP says. Pre-AP doesn't give you that number, so you would have to convert here. Okay? All right, so let's calculate. So P times 2.40 moles is equal to nRT, so it's going to be 2.40 mole times the gas constant, which again, because I'm doing it in kPa, I'm going to use this number instead. So it's going to be 8.31 liters ATM. I'm going to run out of space, so I'm just going to write it this way, over mole K times temperature, which is going to be 370 K. Okay, I have to isolate P, so I'm going to divide by 2.40 mole. I'm going to divide by, oh, that's what I did wrong. This isn't right. This is volume. So volume would be 45.00 liters. So that should be 45.00 liters. So I'm going to divide by 45.00 liters. That is my fault. You know, once you teach, you are tired at the end of the day, so you just make mistakes. But you should know how to plug into equations. Okay, so these cancel out. So I'm just going to multiply 2.4 times 8.31 times 370. I'm going to divide by 45. And just to review my my significant figures, I know that 370 is technically two significant figures, so that would be wrong. I could do 3.70 times 10 to the 10 raised to the 2 if I want to, but I'm just going to go ahead and tell you that it is 3 significant figures is the least amount. Okay, so if I want 3 significant figures, it's equal to 163.984 kPa. If I'm rounding significant figures, that's going to be equal to 164 kPa. Okay, so let's look at a different problem, and let's hope that I plug things in right this time. So 72.0 liters is going to be my volume of carbon dioxide is held at 3.40 ATM. So pressure is equal to 3.40 ATM, and a pressure or in a temperature of 224 K. How many grams do I have? Okay, so if you are looking at the equation and saying, but I can't solve for mass here, you're right, you can't, but you can solve for mole, and the mole can be converted to mass. So let's go ahead and do that. Okay, so I'm going to use 3.40 ATM times 72.0 liters, because that's what volume is, equals N times, and now I'm going to use the 0.021 liters ATM over mole K because this is an ATM. So 821 L ATM over mole K times 224 K. All right, now I am isolating N, so I need to divide by this side. Right, I'm going to be sure to use my parentheses so that I don't break my order of operation, because that is something that causes a lot of problems. Right, and those cancel out. I'm going to go ahead and write it here. It's not 22.4. It's 224. Okay. Okay. So then I'm going to put these in parentheses, make sure my orders of operations are good. Okay. 3.4 times 72 divided by parentheses 0.0821 times 224. Okay, so I'm going to look at my significant figures again, and I should have 3 significant figures. N is going to be equal to 13.3 moles. But it didn't ask for moles, it asked for mass. So now I have to do 13.3 moles. If moles is on the top, moles needs to be on the bottom. And whenever we're doing conversions, it's going to be 1 mole is equal to grams. Because I have carbon dioxide, 12.01 plus O2 is 32. Okay, so it's going to be 44.01 grams. I'm going to multiply that out. 13.3 times 44.01. My answer is going to come out to 585 grams. Okay, so other than that, this is just a matter of plugging in to PV equals nRT. It is pretty simple, as long as you don't plug in your moles for your volume. Just make sure that you do your pressure conversions if you need to, and that you know how to convert between moles and grams. And do not fall into the pitfall of using degrees C. Always use Kelvin. Okay? If you have any questions, please let me know. Have a good rest of the day. Bye.